All right, it's 5 past the time. Let's get it started. Welcome to May meetings, Dynamo user groups. There are a few new faces here. Welcome. Hope you can coming back to our next meetings for the rest of the year. If you sign up, obviously you're going to get automatically into our mailing list. So every month you're going to get an announcement. All right, so Dynamo user group, our blog is on the screen. Contact us via email if you want to present to the group or if you have suggestions about what you want to see. We also are very active on Twitter, at BIM SFDUG. And we have a few announcements. Colin McCron has stepped down from our committee, although he is on the line. We're going to miss Colin. He was an active member of our group, and he moved to Boston. So we wish him the best of the lucks. I believe he's going to be active at the Dynamo user group in Boston, and he's still going to be reachable. So it's not that he's gone forever. He's still going to be a contributor to our group whenever he can. So hi, Colin. I know you're mute, but thank you for everything you did for the group. We also have a new volunteer, Cody Winchester from Gensler. He is not here, but he's going to start participating in our meetings and contributing to our group and with his ideas. Nice to have him with us. This month, Note of the Month, it's brought to you by ListMap. And Jeremy is going to present this at the end of the meeting, so stay until the end, and he's going to dissect how ListMap works and how it can be utilized in different applications. So hang on. Next month's speaker is Jeffrey McGrew with Because We Can. If you're not familiar with the company, they've done a lot of amazing work with computational design and the fabrication end. So Jeffrey is going to show us some of the work he's done in the computational design area, and an announcement is going to come at the end of next week. Call of speakers are always open. If you're doing work with Dynamo and you want to come here and present to yourself, feel free to take the spots. And thank you again to our sponsor, ID8 Inc. They are the gracious facilitators of food and drinks. Look forward to working with them for the rest of the year. So we have two great speakers today.
Go back 1 second.
Yeah.
Last meeting, we actually talked about having people volunteer for both the Note of the Month and the education. So they're not as long. We're looking at the education of about 15-minute presentation, very small. Note of the Month is your favorite node, 5 to 10 minutes. So a little bit less intimidating, but we're taking volunteers from anybody here, really. So.
Just come forward to us or email us or let us know.
It's a good way to ease into the bigger ones.
That's right. Thanks, Jeremy. So on the line we have David Baldacchino. He is a Firmwide Design Technology Manager for HOK. He is going to present a topic on clearing testing with the Geometry.DoesIntersect node. David is currently located in Texas, and he's connected online. So, and after his presentation, I'm going to have Alexandra Bergin present the Revit performance analytics using Dynamo. Welcome, Alexandra.
Thanks.
And with that says, David on the line, it's all yours from here. I'll make you the presenter. And you can go from here. on our conference room, there's about 20 people. David, we can't see you, but we appreciate your time in presenting this topic. David, I'm not sure we hear you. What is it? Hey, David, if you hear me, we don't have your audio.
Can you hear me?
Now we can.
All right. I don't understand why this headset does this sometimes. Sorry. So I said this segment will just go through a very short presentation on how to use the DoesIntersect node, and essentially takes an example that I had followed a while back from Zach Kron, and sort of build in collision detection, so to speak. So I actually took the nodes, and I'll expand them in just a second. I took the nodes and put them all into a custom node. So I'm going to go ahead and put that in here. So obviously, we'll also go quickly through the process of putting this in a custom node. So I have I can pass the geometry, I can pass the... Do you still hear me?
Yeah.
That was weird.
Fault, sorry.
Okay, that's okay. And essentially, any time that we change the geometry of this bridge, if you haven't followed this example by Zach, it was about an hour long if I recall. Up here there's the YouTube video. I basically followed him and built this bridge, and during the presentation Zach said, hey, it would be nice if you could do something a little bit more automated in order to find where your supports don't comply with certain clearance requirements. So that's what I ended up doing here. As you can see now, if I change the geometry of the bridge, you can see where those supports turn to red, or they disappear. And we're going to walk through the process of building this custom node, or the set of nodes that allow you to do this. I'm running version 1.0, and in fact they fixed one of the problems I had come across in the past with refreshing, so that's very nice to see. And we're going to just go through what this node actually does. So I'm just going to go ahead and remove it. And I'll start by placing the geometry DoesIntersect. And this is central to what's going to happen here. So I'm going to take all the elements that I want to test and collide them with this form right here. In this case, it's just a surface that's thickened by 10 feet. So as you can see, if I change the value, the form gets thicker. So this is basically a clearance mass or solid, and it can also obviously be turned off so that it's less distracting. So we pass the geometry here. We're going to pass all the lines that we want to collide. In this case, I'm just doing the slanted supports. I'm not doing this the curve, which we can do as well. But for simplicity, I'll just leave this as is right now. So I'm going to take these lines and pass the geometry. And then the entity that I'm going to collide is this solid that we just hid. And I'll pass it to that. And I get a list of true or false. So what I'm going to do is use these results. Obviously everything is false right now because nothing's colliding. If I change the, let's make this steep like this, and you'll see that we have a few true values, which means that some of these are colliding. And if we click on this node, actually not this node, we have to filter our list with the results of this list. So next thing that we're going to use is the filter by Boolean mask. Which is one of the most popular nodes, at least that's how I find it to be very useful. So I'm going to take now the list, and I'm going to pass this as a mask. However, in this version, once you do this, later on we're going to have to flatten it because I found that there was a slight difference between version 0.9 and 1.0. So you always have to be careful and test out your definitions from version to version, because minor tweaks, minor changes might cause a prior definition to fail. So now we have a list of lines that is being filtered, right? So if we inspect that, if we use the watch node, we'll see that it is outputting a list of 4 lines, and that list right there, if I click on each one, you'll notice the labels here, so you can actually inspect and see which lines are colliding. And there's also an empty list in here. So next, what we need to do in order to highlight this, we obviously can go ahead and perhaps place a node to color these lines. The problem is that then you have to go through this definition over here and start hiding lines, because the colored lines sometimes get sort of encapsulated by other copies of these lines, and you won't be able to see the results. So instead, what I decided to do is to do a poly surface by sweep. So I'm going to do poly surface by sweep and use a rail in a profile. So for the rail, we're going to use this set of lines, and this is where I saw a difference between 0.9 and 1. We need to also flatten this this list. So instead of just getting a list nested inside of another list and an empty list right here, we flatten this, and you'll see that now it's just a list with 4 items in it. So we pass that as the rail. Now we need a profile. So for simplicity, I decided to use just a circle. So I'm going to use the circle by plane and a radius. So notice here that the radius also has a default. So nodes, as you might know, the input of each node might have a default value. In this case, the value is 1. And then because I'm working in feet, that means it's 1 foot. So I can even leave it out without giving it an input. It's going to assume it's 1. And I can pass that as my profile. As you can see, there's an error right now because I still have to remove this node here. I still have to define the plane. So the plane, since I have the lines here that are being filtered and passed through flat node, now I need to just create a plane at the parameter. I find this node to be pretty easy to use. It's curve.plane at parameter. It also has a default value of 0, so we don't actually need to do anything with it. And I can take the series of lines And notice over here we have some planes that appeared. Just so you can see what that means or what that does. If I give a 0.5 for the parameter, you'll see that they go in the center of the line. I'll go ahead and orbit just a little bit so that you can see them. Notice the planes right here on those lines. And I can also then pass this as my plane, and there are the little circles that I can use to sweep the poly surface. The other thing I found also is that now this is failing because it doesn't know what to do with a list and a list. So if you adjust the lacing to longest, then it understands that it needs to take the first item from this list, take first items from this list, and create a poly surface and cycle through. I'm not entirely sure why that is happening, because the lists are the same dimension. In this case, there are 4 items and 4 items. So lacing set to shortest, if I understand it correctly, should still work, but it's not. I'm not exactly sure why. It has to be set to longest for it to work. So finally, to sort of annotate this and make it a little bit more clear what's going on, let me readjust my screen here for a second. And I decided to use the display by geometry color. So I'm taking the poly surface, pass it here, and then do the color by RGB, ARGB. Again, these have default values, as you can see. And I decided to make it red, so I'm just simply using a code block and put the value 255. And as you can see, it's colored red. Now, it's red here as well, but it's hidden because they're coplanar. The surfaces are coincident. So all you need to do is basically stop this from previewing, and then you can see this node essentially taking over. And that's pretty much it for what exists in this custom node collision that I'm calling collision detection. I simply then took these nodes right here and said create custom node, new node from selection. And it did a pretty good job at creating the node for me. I did make a few other changes to it. So if I go back to the node, I wanted to highlight a couple of things that I did. I decided to add a default value for my radius. Instead of leaving 1, I wanted the default value to be 0.5. I was just experimenting and understanding how default values work in custom nodes. Renamed the nodes to whatever I wanted them to be over here, the labels essentially. And there was another output that I actually did not need and removed it, just a simple delete. I saved it, and you get the custom node so that you can reuse it instead of having to do this whole thing every time. The result is the same. The nice thing about it is that you can then, play around with whatever that you're trying to accomplish, whatever your structure is, and you can adjust and make sure that, for example, I can offset the arch here, and now I know that at this position I have the clearance that I need for someone to pass over the bridge and not hit their head. There's a 10-foot clearance all the way across this pathway. So let's see. Are there any questions so far? The other thing I was going to mention also is that, for example, right now I am only checking these slanted supports, whether they collide with that form or not. A couple of things you can do is to put more geometry in a list. So instead of just passing the list of lines, these lines right here, I can create a list, or take lists and join them and then flatten them. And take, for example, this top support, take the individual slanted supports. As you can see, I get a list. I have to flatten it again. Now I have a list of curves, and I pass that to the geometry. Oh, sorry. I did something wrong here. Let me see here. Yeah, not exactly sure why that happened, because I tried this earlier and I had success running it this way. So I'm not exactly sure why. Definitely doing something wrong here, but I can't spot the issue right now. But essentially, by doing this, you take whatever geometry you want to test and pass it to the Geometry.DoesIntersect node, and if it collides, then obviously it will continue passing it and build a rail on it. Build a profile, sweep a profile on the rail, and create like an extrusion for you. Oh, that's right. Sorry. Yeah. Thanks, Jeremy. I knew I was doing something wrong. So basically, this over here also would need to receive that as a list. There you go. So now it seems to be working as expected. Oh, sorry. I'm going to close that out. Now it seems to be working as expected. All right, I think that's it for the learning segment, unless there's any question I can
quick
help
question.
answer.
Quick question, David. In this case, you extruded a circle as a way to visually indicate what's colliding.
Correct, yes.
We could technically just change the color, right? And not extrude anything.
Yes, yeah. You can change the color of the line. The problem is that when you have coplanar surfaces or lines on top of lines, you really don't have control over which line is going to be above and which one's going to be below. So, for example, if I simply took the as I was pursuing this, I was also curious to figure out a way to use the polysurface by sweep tool, for example. But that is what you're saying is correct. But then what you have to do is that once you get the list of lines that intersects, in this case it would be this list right here, you can pass this directly to the as the geometry, essentially, and not build anything. But as you can see, those lines sort of get hidden, so you have to then go through and start, removing the preview of different lines.
Oh yeah.
Let's see, which one else did we have? I think so that's not previewed either. Oh, there's even more. What am I missing?
I wonder if the color actually override lines and not just.
I tried it. Yeah, it does because as I was playing around, that let's see here. Why isn't it? Let me delete these. Weird. Earlier, I was able to change this to red as well. There you go. Somehow, I think there might be, there's another copy of those lines. This kind of illustrates why I didn't want to use lines, because sometimes they sort of turn to black. See, it was still black. So you end up having to turn off a lot of preview geometry that I didn't want to do. So I thought that adding a sort of sacrificial surface that only shows up when there's a collision detected would be easier.
So but that means that there are multiple lines drawn on the same location at the end of the script? We just see all.
Sorry, what is the question?
Does this mean that there are multiple lines, that Dynamo draws multiple versions of the same line, one on top of the other at the end of the script? And just they happen to be all black, so we can see them.
The question was if
you pass the line into a new node that's using those lines, yes, it's going to be duplicated.
Well, right now he was hiding some of the previews. That means that actually Dynamo draws those lines over and over for each node.
I think that's what the preview upstream does.
Yeah.
It replicates the geometry in every node. It's
Yeah.
utilized.
This right here.
Yeah.
Seems not.
Yeah, so like for example, I've had a hard time also understanding how the preview upstream works, but my understanding is just like Cesar saying, if you disable this, it means that anytime this list of lines is used now, don't preview it anymore.
Yeah.
So if you uncheck that, technically from here on out, that line is only exists here, or if it's coming through somewhere else, I'm not sure. Let's see. Well, it's still coming through, even though I said don't preview upstream here, which is this is what I was explaining. What I have a hard time understanding what this preview upstream really does, because it feels like it doesn't work consistently.
All right, we have a comment from Colin here.
All right, I was afraid to say that because I know he's online, but
Preview upstream is only used with watch nodes.
Wow.
Okay, so which means that whether this is on or not, the geometry is still going to display.
Yeah.
Okay, perfect. Okay, so that explains why I wasn't understanding, or at least my perception that when you turn it off, you don't see it displayed anymore, and the preview was not how it behaves.
All right.
So, all good. Thanks, Con.
Any question for David? Good, David. So, if you don't mind, if people want to see this definition on our blog, do you mind email me the DIN file?
Absolutely, yeah.
That's fantastic.
Yes, I will.
All right. Let's. Thank you very much, David.
You're welcome. Thank you.
Applause. All right.
And I will continue watching from home.
Excellent.
Or recorded.
Excellent.
Thank you.
Thank you. All right. The turn is for Alexandra. I'll make you the presenter.
Sorry, guys.
It's okay. He's going to record.
Right. It's with the microphones over there, not the one on my computer. Okay. I'm really loud, so I don't know if you want that so close to me, to be honest with you. I'm going to, like, scream into it. Okay, so for those of you not in the room, are you able to see my screen? Are we good? Yes, we can see the screen? Awesome. Okay, great. So hello, everybody, digitally and physically. I'm Alexandra Bergin, and I work at Autodesk. I actually just switched teams. So in the last 2 years, I've been working in the enterprise support organization with my colleague Danny here. And I've worked closely with Colin in the past. He obviously just moved to Boston and changed organizations. But, you know, as a part of support for, you know, primarily supporting large AEC firms in Revit, I've been on a mission to find better ways to really understand Revit project performance at different scales within organizations. It's a huge challenge. And I've worked with a number of people at a lot of different scales and in different capacities to try to do this. Danny and I have a separate project we're doing to try to address this same problem. And I actually approached Colin with this work to have him help me build Dynamo Graphs that would perform some of the same functionality that I've been looking at in support to try to help spread the word about how you guys can begin to analyze your Revit models and projects for your benefit. So, you know, understanding project performance is really hard. And one of the reasons it's so hard is because for each project, you have all of these different variables that impact project performance, right? And it's not just Revit stuff. It's hardware, project management, the team skill set and responsibilities, the requirements from the owner, and, you know, how well the execution plan's implemented. And, you know, amplify that across multiple projects, across multiple offices in a single firm, and you quickly realize that it's no small task to be able to understand how Revit is used and managed within an organization. So I just want to say that from the get-go. It's not an easy problem, and hopefully some of the stuff I present today will get you thinking about how you can start to try to find ways to solve it for your own special use case and needs. When I think about Revit performance analytics, I really think about different scales of analysis. So, you know, you want to look at different things about Revit, different information from Revit for different scales. Basically meaning at the file scale, we want to look at stuff like the number of families you have and how many imported CAD files you have. What's the file size? At the company scale, you want to understand what percentage of your template content's being used versus your firm-wide content versus, you know, random Autodesk Seeker, you know, other source content is available, so you can actually provide and manage your firm-wide content across the organization. And in the office and project scale, you know, you really want to understand, like, how's my server doing, or how many numbers of users are on this project and when. Those are kind of the different ranges of the problem that can be solved through Revit performance or Revit data analysis. And to top all of that off, there's multiple sources to get that information, right? It's not like you can just query a single Revit file and all that stuff I just showed will pop out super easy. You can access that information from a Revit file. Obviously, if it's a project, you have a collection of files. And then the journal, the user journal, is going to have other information that will impact performance. And then your server information can impact performance as well. So there's all these different sources that you can go to try to find information. And the hardest thing really is to synthesize and to be able to represent that information in some sort of way that helps you generate meaning quickly. Now today, you know, I don't want to get you too excited. We're not going to solve this whole problem, and I can't, it's like at a click of a button, figure out everything for your firm. The things we're going to focus on are these specific analyses. So at the file scale, you know, obviously we're not looking at server information, and that's totally outside of my technical expertise and capacity. But I imagine it can be done with enough gusto and effort. So we're going to look at, you know, content in a Revit file, what's loaded versus placed, and, you know, CAD. How much linked CAD do I have in a project, or how much imported CAD do I have in a project, and how do I figure that out using Dynamo quickly? And then looking at a journal file you know, what's this file size? How many add-ins are loaded into the user session for this person? What is the graphics driver in use? And what's the build of Revit that's being used? That's really deep level support information that helps. So even if you aren't the person in your organization that supports Revit, you know, I think a lot of people who are sort of like in a BIM management position want to know this stuff quickly. But even if you don't and you have a file that you have a problem with, being able to extract that and quickly share it with someone who's going to support you will make your problem get solved faster. All right, so the general workflow for today, and there's a number of ways we can do this, but we're going to pick a simple one, is, you know, you have your data source. So in this case, we're looking at a file or a journal, and you're going to extract data from either of those sources through Dynamo, and then you're going to sort them and re-display that information in Excel in a digestible way that you can then generate charts and graphs from. That's the workflow I'm proposing. And I'm going to propose it over 3 examples, or 3 graphs. They are generally complex, except for the imported CAD one. And, you know, like I said at the beginning, I approached Colin as a support specialist at Autodesk and said, Colin, help me do this. So, you know, he's on the line. So hopefully if something he helped me with I can't answer, hopefully he'll be here to jump in. We're going to start with the journal parser. So I don't know how many of you guys just love to sit down and read a journal file, but it is
They put me to sleep.
they're rough, you know, they really are. And they're cryptic and they're intimidating. They look like, for those of you who've never even gone there, they look like this screenshot that I have on the left. You know, and there's a lot of stuff in there that's not helpful for you. And the stuff that you need to know quickly is really buried in there. So what I've done is I've pulled out some example lines from the file here, larger on the right, for you to get an idea of the kind of information that's embedded in a journal that you can extract through Dynamo and then show in Excel. So one is the build number of Revit. You know, what version of Revit am I on? What's the last update I installed? How many add-ins are loaded on my computer? This is a really big one for BIM managers because users can get add-ins from a bunch of different places and put them on, or, you know, just to get a general understanding of what the Office add-in landscape looks like. Another addition to this that you could have done that we're not going to show today is you could actually track through the journal which add-ins are used. So, you know, if a firm pushes out a bunch of, you know, Revit installs with 30 add-ins, every time you open Revit, it loads these 30 add-ins, but only like 6 of them are used in an office of, you know, 500 people, you realize quickly, like, wow, I really don't need all those add-ins anymore. So that's one way you can take what I'll show you today and then take it to that next level. Other stuff, you know, what's the file size? Obviously, you can like look in Windows Explorer, but a great thing to do I'm trying to help do through this presentation is get you to consolidate all of those data sources. And then, of course, what graphics card you're using and what the driver is. The journal does this thing where after it reports what driver is being used for your graphics card, it lists the certified driver, the Autodesk certified driver for the graphics card in the journal. So another thing that you can do, which otherwise you have to go online, you have to go to Autodesk website, and you have to be like, what is a certified driver? It's not hard information to find, but it's an extra step, and it's in the journal. So in this example, we're ripping that out and comparing it to the driver version that's on the computer. Actually, this is from my computer, and my driver is not certified. So I'm a bad Revit user, too. Okay, so I'm going to go ahead and just pull this up first and walk you through the graph, and then we'll go back to the PowerPoint presentation, and I'll introduce the next section. Okay, so just for your general orientation here, this is just the Revit sample file, and then I put a bunch of CAD in it to make it so that we can look at some CAD later. So ignore that for now. But it's, it's the thing that comes standard with any of your projects, or with any of your installs. So I'm also going to share all these graphs at the end of the day. So if you want to like recreate everything exactly and you put it on your project and it's not working and you want to debug it, try it on the sample file, because it definitely works. Okay, let's make this big. Okay, so yeah, all of them are like this too. So we're gonna go slow and fast at the same time, just for digestibility, time, and my sanity. First thing I'm going to do before we even dive in here, I want to show you what the output is, because that'll help you understand what the goal is. And how I approach this in working with Colin is I came to Colin and I said, I have these charts and this data and this source, and I know a little bit of Dynamo, and I've tried, and can you help me take it to that next level? So I started with my end result, and I recommend if you are looking for specific information to extract out of your files, really start thinking about how do you want it in Excel, because there's a whole part of just developing these Dynamo graphs, which is sorting the information to output to Excel. And so you really want to understand what do I need and how am I going to format it before I really jump in here and spend a lot of time. Okay, so what I've got here is two different tabs. One is called Journal Stats and one is called Add-ins. All right. So all we're doing is we're reading a journal file, right? And that is this guy here. And this is like the extent of a journal file. And this is a short journal file. This isn't even like a long journal. This is like open the file, draw a line, and close the file.
Now we know how to use Revit.
Yeah, it's a lot. They can get really, really long. So that's the source for the data, right? And then from there, we're pulling out those lines that I showed in the PowerPoint, and we're extracting the information that's actually useful to us and killing all the other stuff that's confusing. So you can see, here's the file size. This is the build number. This is the video card. This is the driver in use. And then we're checking to see if that is the same as the certified driver. And in my case, it's not. So that's kind of the goal here. The other tab is add-ins, right? So these are all of the add-ins on my machine that are loaded. And I will go through how to get this information. So, I'm not a heavy add-in user, as you can see. Okie doke. So, step one, you got to get the journal file and you got to read it. Obviously, you're going to want to, browse to a file. We found that doing the read from CSV is the ideal one because the way it formats, the way it reads the file is it breaks up all of the strings where there's commas. So if we look at it, it makes these nice cuts in information that makes it a lot easier for you to extract information from. If you do it, if you look at it in other ways, like a general text file or something, it doesn't break up the information, and it makes it a lot harder for you to be able to extract the information you want to see. And you can see there's a lot of notes in here just to help along the way to understand what the rationale is behind some of the things that we chose to do. There's a bunch of null values with empty strings, and we just wanted to get rid of those, clean them up, make it easier, make it cleaner. And then what we've got over here is just every single value that's on that Excel file is now in a little group so that you can understand how we do each of these steps. And they're not all the same. They're all a little different based on the kind of information that you're pulling out. One thing that Colin recommended doing that I really liked that was super helpful is he has this trick here that we put in, and using a code block as a pass through to then start your group. So basically all this does is it takes this thing and it just starts that data here. So instead of pulling this directly into stuff, it's just a kind of great start spot. And I really like that. That helped me understand where the stuff was coming from and what it was. So I don't know if we should go over all of this. I'm worried that I'm going to consume a significant amount of time explaining each little piece here. But I'm going to explain the general, just the general idea here. And the general idea is that once you get the data and you get to the right level of the data that you need, you want to search for a code word that's in the journal based on the information that you're trying to extract. So if I go back to the PowerPoint really quick, this information here, right? Like file size, for example. File size on open. That's the first one we're looking at. So we search for that. The string contains the file size on open, right? And then we try to find that full row, so the full string that has that information. And then we clean it up. And after that, something that we have to do is we don't want like the whole thing. Otherwise, it's almost as messy as the journal. We want to see it really clean. So what you do is you basically the way in which this breaks it up is it breaks it up everywhere there's a colon, and you can count the value or the number of characters before and after the colon to be able to understand how much of a string you want to grab. So that's what we're doing here, right? That's what this information is here. The description is that everything else here is designed to neatly give you all the characters following the last colon up until the end of the string. So if you look at the entire string, you will see a colon, and then you'll see like the build number, and that's what we're doing is we're using that as a location point and then grabbing that additional information. Lastly, before we go into Excel, when you have numbers, one thing to know is that Excel cares whether or not you have a piece of text or a number. So if you want your numbers to be considered numbers in Excel, you have to actually translate them to numbers in Dynamo first. And you can see that in the Excel file. If you look here, the first one, you see how this is represented all the way to the far right, and nothing else is. None of these are really considered numbers, but this one is. So Excel's treating this differently. It's a different data type than the other ones. This is the stuff that can really screw you up because you're like, well, why aren't things melding right, or why aren't things calculating properly? And it can be just little stuff like that. So this one is the exact same as above. It's literally the same theory. And as file size. So one thing that's nice when you start parsing these journal files is you can actually, once you got your sort of base line graph, you can start copying, and then when things aren't working, that's when you have to start trying other new things. The video card and driver, for example, what do we do here? There's a couple different things that had to happen, because if you look at the string, it's one string, but it has the card and the driver information. So we actually had to split it up. Whereas the other one, we just took the one piece, found the little part of information we wanted, and then pushed it out. In this one, we needed two pieces of information. So you split it, and then you we did a lot of trimming of white space to make sure everything was formatted right, and we were able to calculate those. How we're measuring is we've been calculating the number from the colons of values. So we want to make sure that we don't have any empty spaces in there that we're misidentifying information. Yeah. So how this one works is a little bit different, though, because what we've got going on, where is it? Let me see if I can find it. When we split it, what we did is we split it everywhere there was this quotation mark. And what that did was it put one single string into a bunch of different lines. And that was incredibly helpful, because then if you look down here, you can begin to see like, oh, now I can find the part that I need. Like driver, I see is number 8 list, and I need the information in number 9. So I always need the information after the driver index.
Can you show quickly the actual journal
Yeah,
with this information in it?
the journal file?
Yeah.
Yeah. So if we want to do that, the best way is to, I'm literally going to copy this. So if I just like search for video card environment, I can probably find it actually. But journals, you know, they're unwieldy. So I just do like a Control F. There it is.
Okay.
So it's just like I have it in the PowerPoint slide. Except for in the PowerPoint slide, it's a little bit bigger. But it's a single string of information. And in this case, unlike the stuff up like above here where you see certified drivers and then a number, this is like a long piece of information that we need to extract only one little section of information from. So that's what we're doing right here in Dynamo, is we are trying to split that long string out so that we can get only the little pieces we need. And in this case, we're getting the card and the driver. From there, just like the one above, the two above, we're using that same method to grab what the supported driver is, which if we go back to that journal, you can see is right above it. I think I just saw it. Certified driver, right? So we're just pulling that out of there. And then doing a quick comparison, just a true or false comparison to see like, do they equal each other? And if they don't, then please write in the Excel file, which I'll get to, that they don't match. If they do match, it'll say true. So the last one are the add-ins. And the add-ins are also a little bit complicated because they, like the example above, have this like sort of long string of information that you have to pull through. So I think maybe it will be helpful for me to show you that first. And I guess actually I'll do a Control F and go to Dynamo. This Dynamo is an add-in. So this is what it looks like in a journal file. And you don't need like all of this information, right? Really, I just want to know what the name of the add-in is, right? So that's what we're going to do, and we're going to pull that out into Dynamo. The funny thing is that the way in which Revit works is they have the default add-ins that come when you install, and then they have the ones that users can install. And they're actually organized and represented differently in the journal, I found. But it's a very simple difference. So we had to account for that in this component of the graph. In the other version, you will see like here. I wonder if I have the. Oops, sorry. Here you can say it says name, imports, and families. And the one I just showed in the journal, it says text, : and then the name of the add-in. So that kind of messed us up at first. We were only seeing like 2 add-ins until we realized, oh, there's just 2 different ways to extract that information. So that's what this is about here. This whole section is trying to address that issue. But it's generally the same at the beginning. You just select the whole string, you stick it in, and then you have to take the information and parse it out so that you can better understand what you're looking at here. So this is if you end up using this graph here, this should help you understand that what I just explained to you, right? And I can show you how this is working. So if we let's see. If we go to this one, this is the first list of add-ins that are the user created add-ins, right? So basically what's going on before this is it's saying, show us all of the information in rows 1 or row 2 because they go right after one another. It's going to be either name or text, and text always follows name. So in this case, we have just a couple that fall under name. And then in this one, you'll see you have a value here, but it's not the correct value until you get to text, right? Because it still populates information here. It's just not the name information. So what we're going to do is we're going to weave, basically, and undersort these so that we only take the first ones here and then the last ones here. And how you do that is you basically say, in this list, or group of lists, if the name has only 5 characters, then ignore it, right? Because that means it's blank. But then if it, that's how it takes these, and then it takes the rest of them in a similar way, and then you basically combine the 2 lists here and then shoot those to Excel. To weave them together, you basically, there's a trick in here to do that, where you have a lot of different these little, let's see if I can find it. Where are they? Where are those little guys? Maybe I'll never find them. This is the final. Here they are. I'll never get this thing to stay. Come on, little pin. So you basically once you've created this list of both of them, it's taking both rows for each list and then putting them together, but ignoring any one that has a blank after name. After that's happened, what you end up is you have a series of lists with 2 things in them, and you want to take the first item for the first couple of them, and then the second one for the second, right? So we're doing this trick here that you're basically choosing which one to take in order to weave them properly, and that's what this is here. Okay, so then you have to put it all into a single Dynamo file. Excel file. And I don't know how familiar you guys are with putting Dynamo information into Excel. There's a lot of different ways that you've got to do it. And the most important thing to know is that your data has to be formatted in a 2-dimensional list. Excel really cares about how your data is structured, and so a lot of the work you need to do is just mapping it. Is that the node of the month? Yeah. So Jeremy will go into depth about.
You've just been using it all over the place.
Yeah, I've used it a lot. So I almost wish that you had gone first, because it would have been a really good segue into our presentation. Yeah, there's a lot of list mapping here, so it's good that we're presenting on that tonight. Where was I? Oh yeah, so you have to get the data formatted properly, and then you have to make it so that you have, titles for all of your different sections, and then you push those and combine them to create the final Excel file. One thing that we did to make sure, there was concern about, if we have multiple pages of Excel information being written at the same time, one concern doing it all in one node is well, what happens if I I write it, and then it tries to write the other one, and it overwrites the other one. So Colin, to make sure that didn't happen, devised of using list.combine to ensure that the order in which the sheets were written would make sure that they basically didn't overwrite each other. So I thought that was a really good thing to think about, and it's certainly something that I would recommend you copying if you're trying to write multiple sheets of information to a single file. I've done it the other way, where basically, since I'm not as sophisticated, or I don't have as beautiful graphs as Colin, I'll like copy and paste this and like make two. And I haven't had too many problems with it overwriting, but it's, if you know, the more explicit you can be, the less likely you're going to run into problems. So I'm going to show two more example graphs, and before I do, I'm wondering if it would be good, well, I'm wondering if I should hold questions to the end, or if I should. Do you guys have any quick questions about the journal parsing before I move on? Because I'm going to show two more things, so I don't want to take too much time, but I also don't know if going back later is going to be in the cards.
Just a question. Can a Revit file be edited through a journal file?
No. That's a good question.
Does Dynamo support regular expressions for parsing?
I have no idea. What's a regular expression?
So it's a way of parsing text through almost like a pattern. So it's like you write a pattern in a single line, and it contains kind of groups.
Yeah.
It's a method for parsing.
Theoretically, if you were doing it in C# or Python, yes.
Not out of the box.
Yeah.
So I tried to do all of this out of the box as much as possible. There's one Python script in the three. There's Colin saying it too. You could make an add-in. Hey, there you go.
Yeah, so you'd have to use one of the add-on scripting plugins to do that, or packages.
Yeah, and I tried really hard, even though, like, sometimes when I was working with Colin on this, he'd be like, well, we could do this with one node in a code block, and I'm like, no, we're gonna use the regular nodes, because it really helped me understand the process, and I thought it'd be better for sharing to a larger audience. So yeah, there's probably some optimization that you could do on these.
Just in the whole thing of design scripting confused everybody.
Yeah. Right. Yeah. It's confusing. So, are there any other quick questions before? Yeah.
I wanted to make a quick comment about the add-ins. It might be easier to actually just parse the two folders that load add-ins and read the add-in files.
Oh, from straight from Windows Explorer.
Yeah, straight from Explorer. Yeah.
That's a really good.
I mean, you could do it in
Call
Dynamo too.
directory,
Just
call
pull up the
library.
add-in manifest files.
That's a really cool idea. So that's not one data source that I had listed in my PowerPoint, but it's definitely a relevant data source. So, yeah.
It would definitely be more performant than
High performing.
reading a journal and parsing it.
What
Yeah.
you have to do then is you'd have to pull the current user.
Well, you could, yeah. It should be
That's
easy to
true.
read in the add-in.
That's true. So that's a good point. So if I'm supporting you and you're like, I need help, and I asked you to send me the journal file, then I may not have as much
Right.
success.
That's
So
true. Yep.
there's and that's something to know. Like, there's benefits and drawbacks to all of these. One thing I don't have listed on the final that I'll just say now is that a journal file is, it's a session-based file. So if you have 1,000-person organization, one user generates a lot of different journal files. So, like, how realistic is it for you to collect all of the users' journal files to understand your landscape? I'm not so sure. So there's a scale issue with what you're able to analyze and at what level with Dynamo that you should really be aware of. And we can talk more about that at the end. Okay. So that was journal files. Wow, those are exciting. Hopefully you guys had fun. The next thing we're going to look at is really, really different than journal files. It's loaded families and projects. Okay, so why are loaded families important in projects? Well, families take up a ton of memory, and users do crazy things with families all the time. They make crazy families, and understanding family size is really useful. It's not something we're doing today. They'll put like a giant piece of 3D CAD geometry in a family and then like populate it 1,000 times in your project and then wonder why the file's crashing. But it can be really hard to understand when you're just looking quickly at a file. It's really hard to triage that and to know. Another thing that's so important with families is the origin of the family. It costs a lot of money and time and energy to manage and maintain firm-wide Revit content. You have to do it by version, right? So you got your 2016 library, your 2017 library, your 2015 library, etc. All of that has to get upgraded. You have to understand what do we need, what don't we need. You have to make sure it all works nicely. So understanding what's actually being used can help you prioritize, what to make and what to trash. Because you really want to be lean and mean. You don't want to spend a lot of time of overhead time investing in making content that no one's using. Another component of that, in terms of origin of families, are templates. Firms go through different phases with their templates. Some firms are like, we're going to put everything in the template so you'll never have to load anything. And then other firms are like, we're not putting anything in that template. You have to load everything. And then there's the middle ground. So just understanding like, okay, well, how effective is the content that I have in my template for the users using it? And of course, it does vary by industry or, practice area. So like a hospital is going to use different content than like a workspace, or like a TI. So, do you make 1,000 templates or do you just keep it really lean? That's a choice that you can make, and you can use tools like this to help you decide in the direction you want to go or to track how you're doing. Another one, just on a project scale, is like how many families did we load in thinking they were awesome, but there actually aren't any placed in the entire project? That's a really good one. That can be a quick indicator to say, oh, we need to purge. Okay, so without further ado, we're going to look at that example. Okay.
Kind of want to see that graph with a project that I've been running Spring nodes in for a while.
Which one?
The family one you're about to share.
This one? This clean beauty? Yeah. So, there's some caveats to say about this file, I will say. But I want to show you, just like the last time, I want to show you the end result first, because I think that's really helpful to get you guys figuring out, like, what is the end goal here? What am I trying to do? So what we've got as a result of this Dynamo graph is a list from that Revit sample file of all of the categories, right? Every family organized by type, right? So if you have more than one type of a specific family, it's going to be listed twice, right? But your type is going to be a unique piece of information. So we're organizing by type. That's important to know, because if you do any sorting or any calculating later, you're going to want to know that you're counting by type and not by family. And you want to filter that out, right? Here we have the count. So this is literally like how many callout heads of this family and type are in my project. So you can see that there's some are placed and some are not placed. And then what we've got going on is we've got a master list of families, and I have some of those that I'll pull up, family names that Dynamo is cross-referencing to be able to tell you what the origin of the family is. So, for example, oh, I didn't open any of those. Sorry. Let's open one really quickly, if I can find it. So if I open, okay, so I just made this up because I had to have information that was in the sample file. But so template families, for example. this is like, you could easily use the same Dynamo graph that I'm going to show you to open up your Firmwide template and just pull me out all of the different families in the template, right? And then I can say, this is my master list. And now what I want to know is, from this master list of families that are in my template, how many of those are being used in this project, right? So some are and some are not. And then I want to be able to make a pretty looking graphic that's going to tell me, you know, what the utilization rate is and what that percentage is. So that's the end goal. And it works. It's pretty great. There's some challenges when you have a large file. So, and we can kind of talk about that at the end in my what's next section in more depth. So just to walk through this, the first thing you have to do is, in order to get the information out of Revit, is you have to say, hey Dynamo, these are all of the categories that exist in Revit. Now list them for me. List for the ones that are in the project for me. And until very recently, there was not a node that functioned that would actually give me all the categories. But Colin made one like a couple days ago after I spent like a couple of months trying to figure out how to do it. So thanks, Colin. Actually, though, he helped me so much with this, I think it ended up catalyzing the generation of that. So working together, you know, really helps, because you end up getting sweet nodes at the end of the day. Yeah, so that's what all of this is about. All of this can be solved with just this node that's in Colin's ampersand package. So there's a little plug for you. Download the ampersand package. It's great. Saves you tons of time. Then the next thing you need to do is you need to filter out the categories where there are no families, right? So it's like, give me everything, and then Revit looks at it and says, well, here are all the categories, but not every category in Revit has a family in the project. So you got to filter those out and get rid of them. And then we get into the fun exercise of, this is actually where building the Excel file starts, believe it or not. We need to sort the data in a way that's going to enable us to generate a final file that looks like this. And what you can see is, if we're like, give me all the categories, Dynamo, it'll be like, well, there's windows, there's doors, there's walls, there's floors. But there's multiple family and types within each of those categories. So the first step in Dynamo, right, so like you can see how many different doors there are, right? And the sample file is kind of funny to look at because there's not really that much stuff in there. So the first thing you need to do is you need to repeat the category name as many times as there are family types within the category. And that way, every time you have a type listed in your Excel document, it's corresponding to the appropriate category in which it sits. The way in which extracting family information works is a little bit easier, because the family name and type are so intrinsically connected that you don't have to do that step above. It will actually already repeat the family name with the type. So you only got to do that for the category, which is great. And then you have your type name afterwards. So we've got our categories, we're repeating them across the family and type. We found our family names, and we found our type names.
Can you not get the family type from the family object? Like, eliminate the box above by using the family and pulling the type out of it?
Well, I think because we want them to be these separate columns for the Excel file,
You still need.
we need them to be in this like very specific way.
Okay.
And that's why, like, re-emphasizing my point at the beginning of this presentation, which is like, figure out, do like a fake Excel sheet of what kind of information you want before you start building this thing, because there's a lot of different ways to approach this problem, and you'll find like Danny is definitely pointing out an easier way to extract the information, but it's not going to format it in the way we need. So, you know, save yourself the trouble and just try to figure it out first. Try to figure out what you want first.
Alexandra, quick question.
Yeah.
This is obviously component families, right?
This is, that's a great question. This should be all the families. But-
Including walls?
I think so. But let me just check because I don't. Yeah, no.
Those are the loadable families.
It's just the loaded ones.
Loadable.
Just the loaded ones. Yeah. There is, I'm not sure if there's a way to get the system families out now that we're talking about it. Danny, do you
I
know?
don't think Dynamo can actually access the system families for the most part, other than the place if you
Yeah, maybe the API doesn't support the system families. Yeah, you're limited by what the Revit API does. What's weird is like if you look at the list of categories, which we can do through. Oh, I'd have to run this. I don't want to run this. This is going to take forever. I'm not going to run it. It's just going to take too long. But it's like the list of categories are not just like content categories. It's like weird analysis categories and other random Revit-y things that you would never know about. So that's why I was like, maybe system families are in there because there's just so many. I mean, I've been using it for a long time and obviously support it. And I was like, oh God, I didn't know that was a category. So there are things that will surprise you when you start doing this. Once you get your little buckets that you need, the next thing you do is you have to count how many instances or elements are in each of these buckets, right? So like, how many single flush doors do I have of each type? And that's what this section is doing here. You got to use list.map, which you'll learn about later, twice in order to get deep enough within the list structure to actually count it at the instance level. So when we start pulling out, we're pulling out initially by category here. And so we're at like a very high level, and then we need to like just dive really deep and nail down. So you actually sometimes have to repeat nodes to just like keep drilling down deep enough. There are some little activities here, side activities that I'll clean up before I give this to you. So now I have to decide how I want to explain the next part. I think that the next part we have to do is the comparison, right? So what we've done so far, which has been really effective, is we've gotten all the way from here to here in our Excel sheet, right? We've got our categories, we've got our families, we've got our types, and we can count them. The next part is it's a two-step approach, right? We have to first find our master document that has the names of all of the families in the Imperial Library, for example. I would, if I was in a firm, this I guess is kind of useful, but I would certainly use my firm-wide content instead. Like how many HOK families are being used in this project, and I would make my master list out of those. But because I don't work at a firm, I'm using Autodesk Firm, which is the Imperial Library. Then a template information and whatever is left over, right? It's nice to know what percentage of this stuff we just don't know where it is. Yeah.
So, hypothetically, say you have ongoing, you have like separate libraries that are both firm-wide as well as like other client-specific families that you have ongoing projects with.
Yeah.
That are specific and tailored for their needs and the workflow of all the team involved with those projects, and then other ones that are just custom even for that project. Can you just kind of like combine like this directory and this directory and this directory, and then compare those versus like is that help? Like, is there a way to incorporate that understanding?
Yep. All you need is an Excel file with a list of what their names are.
Okay.
And there is a caveat to that. Did I open one? Yeah, like this. So all you need basically, and what we chose to do was make category and family, because if you just do the family name, someone could be like door, and there might be like 6 different door families. I mean, I guess that's a terrible example because the category would also be door, but just trying to, or like you could do the size of the family, which you can extract from Windows Explorer, and that might help. The only issue is getting the getting the size of the family from the project, deriving that information is really, really taxing on your data extraction, and Dynamo will probably crash. So you have to kind of pick and choose, but you want to sort of cross-reference these things with a couple different values so that you know that you're not getting overlap. One thing that's nice about like owner-specific or firm-wide content is that you normally have some sort of indicator in the title, right? Like it's like, this is the HOK super door, or, you know, this is owner X special table. So some of that's actually pretty easy to do through name, but I have received some critique about that, generally speaking. So.
How do you get the size out of Explorer?
Out of what?
How would you get the size out of Explorer?
You literally, like, if you from a Revit project,
Well, I mean,
or in general.
RFA. Just
Gonna
get the
do it.
RFA size.
Yeah, you just have to get the RFA size from Windows Explorer.
right,
So
but
if,
can Dynamo read that out of the file structure, or do you're saying you do it manually?
no, so what you can do through the Revit API is you can basically save out all of the families to Windows Explorer and then read that information in Windows Explorer.
Okay.
But it's a slow, taxing computational process. So we're not doing that here because it's, while valuable, it's not quick enough.
That is like writing out a catalog as a TXT
Yeah.
file.
How do you get it into a spreadsheet or a text file?
Oh, you just create one, like you can just like copy and paste it. You just copy, like highlight it
Command
and,
line.
huh?
You use the command line.
Yeah.
And then
Yeah.
Sorry, I'm a command line guy.
He's a command line guy, so yeah, Danny and I work together a lot. I do it a little different. I like look at it, I open it in a web browser, and then I select to highlight it all, and then I paste it into Excel because I'm that technical. Yeah, but it works. You know, whatever. My system's just fine. Okay, so moving on, we've got all of our different buckets and we've got our counts. The next thing we need to do is we need to get our master files, right? We need to get those different files and reference them so that we can compare them to the information loaded in our Revit project. So that's what these are doing here. And there's two different ways to get the information. It's basically the difference of, like, in one, you are just getting the first column of data, like, give me just column A for the names. And in the template family, as I showed you before, we're looking at the names and the categories so that we can do that cross-referencing that I talked about if you want to be thorough to ensure that you don't have false positives. So this is just two different ways to do it, depending on the sort of input that you have from your master file list. And you're basically just reading an Excel file here. That's the story. So now we have our comparison, and what you got to do is you've got to compare it for each different master file. You've got to compare the information. So that that's all that this is happening. That's all that's happening here. This is where the only Python script that I'm showing today exists, and the reason is because when you choose to do that cross-referencing that I talked about in that template families master, where you're trying to say, like, first see if the family's there, and then check to make sure the family and the category match, you have to do it in a specific order. And that is not supported through the use of nodes. So basically, this little Python script is going to make it so that it ensures that that check happens, and it happens in the right order, and it happens in a way that doesn't create, like, some terrible cyclical loop that makes your Dynamo script crash. And then the end thing that you have to do is you have to say, well, what's left over, right? Like, not everything in the project is in the template or in my Imperial library, so I have to have this kind of bucket for the other stuff. This is the unknowns, the Revit City content, the Autodesk Seek content, for example, user-generated content that is saved to a project folder, stuff like that. So that's what we're doing. We're just getting our little lists, and then we're gonna start counting them, right? So similar to before, you've got to count true or false to know how many of these things are in, and then you've got to add them up. And actually, I'm showing that on a different, where is my guy? I'm showing this section on a different sheet here under Origin. So this is going to help you understand like how many pieces of family content are from each of these origins. Just so once we get into this and we have all this stuff here, we don't have to do a ton of work in Excel to try to like then mine out all of it. We can let Dynamo parse it out for us. All right, now we are going to assemble our Excel sheet data. First thing we have to do is we got to flatten them to ensure that they're all in the same like format. Before we didn't flatten them because we were trying to make sure really, really carefully that like, yes, there's a category name for every family, for every type. You really want to count that stuff to make sure it's lining up. But afterwards, then you've got to translate it into a format that Excel can read. That's what's going on here. Then we're just doing a basic like adding our header row and writing the file to Excel. This is the same process I showed before where we have the different tabs. I found that if you're creating tabs, it goes backwards from the way you want them to go. So if you want the master count to be like sheet 1 in Excel, it should be the last thing that you list here. Yeah. And the only other thing I have on here, which was a total side project that didn't end up happening, is I wanted to try to build all of the graphs using Bumblebee. I don't know if you guys are familiar with that. Any of you? So the issue is that like this is to build a pie chart. This is to build this pie chart here. Okay? And the problem is that there are no default values for any of the nodes in Bumblebee. So you have to like laboriously code block out every single value. And I just lost patience, honestly. I was like, you know, I want to press the pie chart button in Excel, and I'm just going to do that. So you can kind of decide if you want to. I left it here just because you might want to, if you were going to use this in a robust way in your firm, it might be worth your time to invest in building these things. For me, to show you guys, I did this for a little bit and was like, no more Bumblebee, no more. So it's a package, and it enables you to build graphs with Excel. Have you guys used it? Did you guys run into the same issue where just the default values killed you? Yeah. So.
I have to spend more time undoing things than doing things.
Yeah. So I think there's value there, but at the same time, it's just a lot of setup. So.
Easier just to pass it back in with Flux and the Grasshopper and use the plugins that are there.
Yeah. If you want to do that, you can just do it in Grasshopper.
Well, hey.
Yeah. No, it's true. It's a lot easier. So that's content in a nutshell. So just to look at the final result again, you know, we have this master count, and then we can break that up into different categories. And if I had had more time in preparing for this, I would have done more. So I have like these other things that I just sort of quickly extracted from the master count list, but didn't have time to do the breakouts within the Dynamo graph. So this is not something that you're going to get from my presentation, but I really do. I have it in the PowerPoint, these different charts. And the idea is that, you know, once you have this giant master count, you can do a lot of different things with it. If you can invest the time in sort of parsing out the data and structuring it properly to generate the appropriate graphs that are of interest to you and your organization. So yeah, if I had had more time, I would have looked at placed and not placed and built out like a separate sheet for that. just by using the counts. Like if the count is 0, it's not placed. If the count is 1 or greater, it's placed. And that's just how you get that information. And then, you know, of those types, you know, how many of them are placed and unplaced by origin, right? So if I was a firm and I was looking at this and I saw this percentage for the template, like this utilization rate is really good for a template. So I'd be really happy, right? But if my template, you know, if it looked like this and my template was orange and this was just like not template content, I'd be really sad, you know, because that means that my template is not serving the people who are using it. So, yeah, that's kind of the next steps for this effort. And I really encourage you guys to take what I've done with a lot of Colin's help and make it your own and make it right for your firm, and then share it, right? Like come back to SFDUG and be like, I built on what Alex was doing and I figured out how to make this part in Dynamo and I want to show you that. And that would be really great, like what you guys were talking about, you know, something like what David did where he walked you through how to build something. That would be like, you could use this as a starter, this graph here, and then just like build out that little part. It'd be really cool to see you guys do that.
So I have a question for you.
Yeah.
Why didn't you just harvest all the placed families, pull the parameters, and parse them out?
Why would I do that?
Because most of the data that you're trying to harvest multiple times are already existing in the elements that you're harvesting once.
I don't understand.
Sorry. The families that are already in the project
Yeah.
would have the data that you're trying to pull and cross-reference.
Oh, no, because, great question. Awesome question. You mean for origin specifically? So the reason why we have the master lists is because, you know, I might have a firm-wide library with 2,000 pieces of Revit content, but my project might only use like 25% of that content. But if I want to have a robust system in which I can look at multiple projects over time and then really understand what that content utilization is at a firm-wide level, it becomes really valuable to have that master list. So when I was in the up here in the presentation talking about the scale, where are we? This part, the scales of data analysis, like some of that stuff with the master file list, it's really only valuable at the company or office level or at the practice or studio level, right? Like for healthcare projects, you know, what do we need? Whereas like at the file level or just for like general triage to understand like how many families are loaded or like, you know, in this file, it's not as valuable. So that's why we took it there, just so you could begin to consider the multitude of scales that you can look at this kind of problem and then address questions you may have or try to solve problems. Does that answer your question?
Somewhat, yeah.
Okay. Any other questions? Or I don't know if there's questions on the computer. Chat.
I have a question extra.
Yeah, what's the question?
You have a list of families, master list. Is there a way that you can import that list into Revit using Dynamo?
Why the list?
If you have a list of families.
Yeah, like batch. You mean like batch load?
Yes.
You can
Yes.
download Express or other tools, but yeah.
Yeah, there are tools to do that, but yeah, you could do, just place the family. Generally they place the family but they load the family, and when you load a family you have to actually place it, like when you do it manually. And so typically those add-ins load the family and then kill the transaction that is asking for the placement. That might not be possible in Dynamo, but
There's a delete node, so you can place the family and delete the family. But
Yeah,
then
yeah,
in
you
the
should do
process,
that.
it's loaded.
yeah, but then you're modifying the document.
Yeah.
You're committing and then deleting a bunch of stuff from your model.
You'd have
Might
to
take a little longer.
use a wait.
Yeah.
Could be
So I guess the short answer is out of the box, no. But just like everything else in the world, in Dynamo in particular, if you want to do it bad enough, yes, you can.
Just go to Dynamo nodes and start searching.
Yeah. Are there other questions?
Is anything inside Does a Revit API exposes the size of a family within a project without exporting?
No, you can only.
There's no way.
No, I
there's
wish.
nothing that is-
No, it's so frustrating. So the only way to get the family size is to literally save out all the families from a project and then read it through Windows Explorer. It's rough, but it works.
You tried ID Explorer?
Oh, yeah.
Access to a bunch of other systems.
That's a good point. I haven't looked at ID Explorer, but that might be something that a tool that has solved that problem. I don't know. Is anyone familiar enough with it to know?
Yeah, it does. It does everything.
Good size, no.
Well, it doesn't do the size. No. And yeah, I think the only solution I've seen so far is to export the data and parse it outside of Revit, which is a problem because sometimes you want to know your top 5 largest families in your project, and there's no way to know until you do this batch export of everything.
But you can, we'll talk about this at the end too. We're running out of time. The last one's really short though, so we're all good. You know, if you choose to not use Dynamo and instead to build this with a plugin, a formal plugin, you can run it at night and just do batch runs. And that would be how I would do that. Just do it at night when no one's looking and go get those. But, you know, then you have to figure out, like, what milestones you would do it at. There's other issues there, so.
Or just archive the file, then purge, and when they start screaming.
Yeah, you can do that, but that won't give you any insight. That'll just solve your problem. Okay, so we are going to go with, I'm going to just talk about the last one really quick, unless there's any questions online, and I'm not seeing any. The chat is very quiet.
It's too intimidating.
Yeah, maybe I bored all these people online. I don't know. I'm sorry, guys. I hope you're there. Okay. Who knows? We may have lost them all. So the last one we're going to look at is the imported CAD instances. So this is a question we get all the time in support. It's one of the first things I look at when someone calls me. They're like, my file's not working. It's really slow. I'm like, I bet they have a ton of CAD in there. So how do you figure that out quickly? This is how. So I'm just going to go ahead and open it. Yes, that should be it. Okay, so like I said, look at a totally digestible and non-intimidating graph. Maybe I should have started with this one, huh? So basically, I guess like all the other ones, I'll show you the output first. There's a lot more I could do with this, but I just kind of ran out of time to be able to show it all. All I wanted was I wanted to know what the file name was of every imported instance of a file, right? So in this sample project, what I've got is, I've got 3 actually files here. 2 of them are imported and 1 of them is linked CAD. Okay, so there's a difference. And then there's 2 different file names. Even though it's the same file, because I'm lazy and didn't want to find 2 different CAD files, I just changed the name. What you're seeing here is floor plan sample and floor plan sample copy. And those are 2 different file names of imported Revit content. Okay? So, in Dynamo, oopsie. The first thing you've got to do is you've got to find the type of element you're looking for in your project, right? And so that is the imported instance type. Now, the next thing you have to do is you have to actually figure out which of those are imported and which of those are linked. Because with CAD, Revit calls linked CAD an imported instance. Okay, so that's kind of annoying and confusing. What you've got to do is there's actually a trick. The imported files have a parameter called shared site, whereas the linked ones do not have that parameter. Okay, So that's super helpful because then you can sort the different basically parameters of the type, so that you only get the ones that contain shared site. All right. So then what we did here, the filter by Boolean mask, is we just took the ones that had shared site parameter. This in is the linked file. So like I said, you could do a lot more with that Excel document that I had earlier. So right now you're just seeing imported instance. We're going to get the name in the next step. But like that Excel file, it can tell you not only, you know, how many imported CAD you have, but also how many linked CAD you have. And you can see like, oh look, this team imported the CAD 200 times and then they linked it 6 times. That, you know, so someone knows what they're doing. Who knows, you know? So it's interesting to be able to look at that and then to use it as a way to sort of target training and sort of educational efforts at the project scale. So the next thing you have to do is you just got to find the name of it, right? Because imported instance isn't very useful. It tells us how many there are and what they are, but we'd like to know what its name is. So we're just getting the name from the parameter value, right? And then we are mapping that and writing it to Excel. And you know, all we did here with the transpose, this is different than some of the other Excel writes that we have in the other examples. So just put a note here to show you like, oh, the reason why you use transpose, just to, like switch the rows and columns in this case. Really simple use case, really digestible and easy to do, and gives you incredibly valuable information that can help you manage your projects quickly. So that said, I have these things to consider, or what's next. I've said a lot of them throughout the presentation. One of them that's really worth reiterating over and over again is that like when you have an actual file that's not the Autodesk sample file, this becomes a beast of a task because you're extracting a bunch of data out of here and it takes a lot of time. So especially with the family counts, the journal file one, you're not going to really have much of a problem with. The journal is going to be long, it's going to take longer. But when you start doing the family stuff, that second graph I showed, one thing that I might recommend doing is breaking up that list of categories into like chunks, you know, like give me the first 5 categories, then the next 5 categories, then the next 5 in different runs, or else you're going to basically crash Dynamo and not get any farther. So think about that. If it's not working, try it on the sample file, and then, you know, it might be that your data set's too large and you need to do some, you know, tricky, deeper considerations in how you want to actually extract that data. The other thing I've already mentioned is that, like, especially when we're thinking about those scales of analysis, if you really want to, you know, do this at the firm-wide scale, I think the best thing you could do is build an add-in or a couple add-ins through the API instead of using Dynamo. It's just a lot more sustainable, and the maintenance on them is lower, and it can take more information out with like one single tool. So with Dynamo, you know, I have 3 graphs showing you kind of 3 different things, and even though we're doing a lot, and especially 2 of the graphs, we could do all of that with one add-in, no problem. So what I'd recommend is to start, you know, especially, you know, you got to get buy-in to do stuff like build an add-in or to contract someone to build an add-in. It's a lot of investment in time. It can be really stressful. A lot of people begin to argue about like what it should be and what it shouldn't be, and it ends up being this whole thing instead of just building a graph. So use the work that was presented today as a way for you to help determine what you really need in your organization as like sort of a petri dish kind of approach. And then if you want to take it to that next level, you're either going to have to build incredibly robust sort of Excel. You could build like a bunch of data, Dynamo Graphs to like combine Excel data, or you're going to really want to invest in that next API step, that kind of higher level analysis. And the last thing I'll say regarding especially like Excel output from Dynamo is that Nathan Miller had a AU presentation on analysis in 2014. I think it was called data mining in Dynamo or something. We went over very different things. He went over room data and stuff like that. But at the end of his presentation, he had some really good resources for sort of managing Excel data with Dynamo and for Dynamo. So if you have a bunch of different Excel files, how do you link them? How do you organize them? How do you make them one thing? And how do you make them work together? That's something that I didn't have an opportunity to present today, but it is available through the AU online website. So I really recommend you guys check that out as an additional resource to today's presentation. That's it.
Any question for Alexandra? That was very good. So the last part of the presentation is to go into the node of the month. So I'll make Jeremy the presenter. Are you online, Jeremy?
I'm here. So I'm just going to quickly go over one of the kind of basic tools that we use in Dynamo when we start getting beyond a simple graph with one or two-dimensional lists. Usually it's when you start to get into two-dimensional lists like Alex was here. So you'll start to see things like we build an array of points, but I want, when I stick a series in, and rather than just every x going to every y, I want to actually see an array of them. So every single one of these goes to every single x. And you're going to have to start using list mapping, essentially, for that. Or repeating. You would repeat them. Actually, let's go ahead and turn this off. This is really just, the first part of this is just how would you build the data to start to need a list map. All right, so we got lists of lists now. The latest Dynamo changes have made it easier to do this without using list map, but there are still quite a few instances where you need this, especially once you start getting into multiple levels beyond just two. And I seem to find myself doing that all the time, so I had to kind of learn this. So go ahead and hide these guys. So, for example, I want to put the boxes on specific, I want to put them on the first of each of the rows. Or I want to put them on the second of each of the rows. But when I simply get the first item from this, I'm not operating on every list. I end up operating on the first list. So I end up with the first list instead of the first of every list. So in order to get the first of every list rather than getting the first list, that's where you need to start using list map. Essentially the way the list map works is you put the function in with one of the inputs open, and that's the list you want to operate on, and then you need to put in the input. The other way that Alex was using it is when she was doing endpoint. No, actually it wasn't Alex doing it. We saw it in the first presentation, where he was using one endpoint with multiple, one start point with multiple endpoints. So his input was the start point, and then he had a list of endpoints that he needed to go to. That's where you'll start to see list map being used, when you need to operate on a single item with multiple items. Generally, you can with the new way that Dynamo is working is that if the data structures are exact, as long as they're two-dimensional, it will kind of figure it out. And the way you can tell is by the inputs. Colin, actually, if you go back a couple of meetings, you'll actually see the talk that Colin gave on this there. And that is a very good hint to whether this will work with a list map or without. Generally, if you see something like a single point, for the most part, you can get away without using list map. It's once you start to see this, the ability to take in something more than just a single item, that you may have to start using a list map. But that works great if you've just got two-dimensional lists. Start to get three-dimensional lists, four-dimensional lists, five-dimensional lists, which when working with geometry and multiple data sets at the same time is very easy. I find myself getting at least 4 or 5 data levels on most of the time when I'm working. And so I was having to stack list maps, like 3 list maps for every single command I was using after a point, and it just became really redundant, really heavy. And it was like, okay, I can either go back to traditional coding, which I don't want to do, or I need to figure out another way. And so I started exploring some things with Demeter, and he started using these brackets, and I was like, okay, what is this? Because I was able to do, he was able to do things in one line of code that took me about 6 or 7 nodes to do. And I found out later that they were, they're called replication guides, and it's essentially, it prevents you from needing to use list map a lot of the times. So what we just did in, you know, almost 8 nodes here, we can do in essentially 1 code block. And the way, what's really nice about this is by putting in these brackets, you're basically matching lists. You're saying that, you know, these lists are equal when the numbers are equal. When you start to do things like, say, they're not equal, so when I have a 1 and a 2 here, I'm basically saying that every list going into this first one gets matched with everything going into this. So it's repeated. It replaces the need for that repeat list for every item in a list. You can start to go a little bit crazier, and you can start to use multiple levels of these and start to generate, with pretty much the same amount of effort, an entire 3D array. And all we've done is add 1 more input with another replication guide. And I think hide that one. So you can actually go a little bit farther with it once you get to this level into things that would actually take you a lot longer to do. You can start to then operate on getting specific items using ranges out of larger data sets. So I had lists within lists within lists, and that would have taken me at least 2 list maps in order to do. You can then start to operate on these nested lists in pretty much the same fashion using replication guides. So that's pretty much it. It actually got a lot easier recently. Any questions?
Is there any node for replication guides?
Nope.
Is it just design script?
It's design script. Some of the new ones have started incorporating, I think they've started incorporating the replication guides, which is why it's starting to get easier. And that's the hints to that are there when you hover over an input.
Yeah, it's pretty cool.
So we can take one of the example graph that I had where we had 2 list.maps.
And you could start to plug in the 1 and then the 2 like this. And then you'd eliminate a couple of nodes.
Okay. Good to know.
This is how you can start building patterns too, right? Because you could have 3 lists and
Yeah.
start picking elements from one of each this list.
You could do that straight out of the box without the code blocks, but you'd end up with quite a few nodes getting patched together. And then the danger with that is that after you get to that point, literally every time you try to run something after that, unless you're flattening and destroying that structure, you're having to reuse pretty much that same number of list maps. Which, if you do that at the beginning, that's a lot of extra nodes. So it's more about what happens downstream after you start creating that data structure. There was a point when I had 6 curves. On every curve there was like 24 points. On every point there was a frame, and on every frame there was 3 points. And then I started doing things to those points. And so I was 4 or 5 data levels deep pretty quick.
Can you clear the pinge list?
Say again?
Can you clear the pinge list? I just want
Yeah.
to see what
Yeah, so that was just another series. I'll put this up on the with the recording.
this is great.
And it made my life a little easier. So who's doing the note of the month next month? I guess you are.
Maybe your new Colin.
Oh, Cody.
Yeah.
We could make him present.
You good to get to know him?
Yeah.
We'll tell him 5 minutes before.
We'll talk on Tuesday.
No, we'll tell him 5 minutes before the presentation.
Okay.
Trial by fire.
He'll
He's
have
been
a-
warned if he's listening right now.
You know, he might have a lot of surprises. All right, guys. Thank you for coming. And thank you, Jeremy, for coming. This is going to get posted next week.
I was half waiting for the question, what happens when I have multiple lists?
Well, it's better than.
That's when those replication guides really start to help. Because you don't then have to use combine. There's situations when combine list doesn't work.
You should do a blog post.
I was waiting for Colin to follow that up after his blog post, but
I don't know if Colin's gonna be blogging anymore. How are you?
Look at hey,
Are you enjoying your work?
hey, Alexandra. Look at Colin's applause.
clap, 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 dot 20. Wait, list.
Only 25 times.
He should have made it, yeah. He should have used some of your list.map stuff to like
Oh,
amplify it.
Replication guides with the series to the power of 10.
With the power of 10.
Thanks. It was, couldn't have done without Colin, but it's really important stuff, so. It's not as sexy as geometry, but.
Thanks for using WebEx. Visit our website at www.webex.com.